Hey guys, we finally got done with our electrical. We're super stoked to show you everything we did and how we did it.
We didn't actually record anything when we did the 12-volt system because we were in such a rush to go to Yosemite, but this time we recorded a lot of footage and we can't wait to show you guys.
In this video, we want to show you guys all the cool features that make up our electrical system.
After that, we will give you a detailed breakdown of all the wiring, fuses, and components we used in this build.
Then Andrew will run you through how to plan your own setup and all the basic parts you'll need.
I'll also share with you guys some tips and resources that really helped me in this process.
Stay tuned after to see Andrew test out one of the internet's fastest electric scooters.
And be sure to like and subscribe to see next week's video where we show you the entire process of us putting this system together.
So we tried to get everything we could for our electrical system to fit in this small area. And we did a really good job, but it is tight down there and it was hard to get in here and work when we already had this bed frame and all these small spaces. First, I'll show you a little bit of our mess right here. This is where we will have two of our light switches. These light switches are dimmers and they're set up to our LED lights in the ceiling. So one switch controls the front kitchen area and one switch controls the back. This is our 12-volt outlet, which we can plug in a USB converter like you would in a car to be able to charge phones and stuff. And then this wire will eventually be another 110-volt outlet, like your normal household outlet. The last thing we'll have over here is our battery monitor. This tells us all the status of our battery. It's currently at 99.6% charge, 13.48 volts, negative 0.2 amps, which is all these lights and stuff that are on, which is 4 watts, 0.8 amp hours have been used out of the battery, back to the percentage. We're super happy we finally got our fan working. We had to get a replacement part. Be sure to check out that video if you want to see how we fixed our fan. But this is wonderful. Fan turns on. It's at max percentage right now. I'm going to turn it down a little bit. About 50. It's blowing air in right now, but we can tell it to blow air out, control it. This will also be attached right to this wall over here. One of the best things about traveling when you have your own battery setup is not needing ice for your coolers. It barely draws any amps. I've actually kept it on just because we get free power from the sun, so it costs us nothing. So it's always on and cold. Right now it's at 33 degrees. You can just slide this out, open it up, and we've got plenty of space to keep things cold. We love this thing. This is our distribution panel. It's awesome. Over here are my fuses for my DC appliances, and over here are my breakers for my AC appliances. We've got this all plugged in behind here. These are extra wires that we've plugged in already so that when we build our countertops and things on this side, we can run these wires and get power onto that side. As well as we have this nice long extension with some extra 110-volt outlets. So it's nice to plan ahead, go ahead and run extra wires, put them somewhere. I don't have the fuses in so the circuits aren't hot. They're just ready to go. All I have to do is plug them in somewhere and drop in a fuse blade and we're good to go. Another thing we added is this circuit for these garage lights. We've got a switch on this side, turns on both our garage lights, which is awesome. So this is our inverter charger combo. This is a 2000 watt inverter. This will invert our 12 volt circuit into 125 and allow us to run appliances that require much higher voltage, like your typical household appliances. I really love this company, the Victron, because of their Victron Connect app. It allows me to connect to all of these devices via Bluetooth. Let me show you. Here you can see all three of my devices on the Bluetooth. I've got my solar charge controller, I've got my battery monitor, and I've got my inverter charger. I'm gonna open the inverter charger first. Connects really quick, and from here I can remotely control the inverter. Instead of having to press the buttons on here, I can tell it to turn on. You just heard it click on. Now my 110 circuits are all ready to be used. Real quick, I'm gonna show you guys the other two. Here's the battery monitor. Shows me that I'm at 100% charge, gives me my voltage, the power being used, all of that information. My solar charge controller, it shows me how many watts we're bringing in, the current from the solar. It's really low right now, but that's because we're in float. My battery's already full, so it doesn't need to bring in much power. Now that the inverter's on, the outlet that we've installed for the 110 circuits in the back garage area, show you that it works. I can plug in my cell phone charger, plug it in here, charging. Isn't that great? Another thing we installed during this was our Shore power plug. This is a 30 amp Shore inlet that allows us to connect to Shore power and charge our batteries. Many campsites will have 30 amp plug-in, but just in case they don't, you can easily get an adapter that will change your 30 amp to a 15 amp. Since we don't have a 30 amp at our house, I'm gonna show you how this works with our 30 amp. So here we just lift this up, we put this on here, and then there's this little water seal that can easily be screwed on to help prevent moisture from getting in there. We already used this in the pouring rain when we were at the lake, and it worked great. No water got in at all. So right now you can see that it's set to inverting. As soon as I plug this in, it's gonna recognize that power's coming into it and it'll change to charging. And not only that, it will run all of the 110 volt outlets off of this power instead of my battery power. Let's watch. See, it just changed. Now it says bulk charge. We're bringing in 230 watts and we're using -30 because I have nothing running in there. But this will bring in as much power as it needs to be able to charge my batteries and run anything that I'm using. That's awesome.
So now, let's take a look under the hood and see how these components are connected.
So to start, we're gonna have a 2-0 gauge wire, which is the largest wire I use in my build, that connects to a 300 amp bolt-on terminal fuse. So that's going to be attached to the battery. This is coming from the battery. So the positive comes into here, and then a positive comes down to energize this positive bus bar. This is my switch that will turn everything on and off. If it's on, then there's power running to this. This 2-0 gauge wire runs down to the positive bus bar. Off of the positive bus bar, this first positive wire, which is also 2/0, runs to this 250 amp A&L fuse with an A&L fuse holder, and then runs from there, and it's gonna come out and connect to our inverter up here. The next cable here, this slightly larger one, this is actually a 6 gauge cable, and it runs the same direction, but it comes out to this breaker. This is a 100 amp breaker, and then it comes out here. This will power the distribution panel, at least the DC side of it. Back over here, the smallest cable, which I believe is 6 gauge. This one runs all the way up and around up here to this 40 amp breaker, which goes to power the solar charge controller. The battery side is here, the solar panel side is here. This positive solar panel cable goes to this 15 amp breaker right here. All of them have negative wires that run back to these negative bus bars. I have 2 negative bus bars. They're connected right here by this 2 gauge wire as well. I also have one of the negative posts attached to the chassis for a ground. There's a lot of information online that says that you don't need to do this, then some say you do need to do it. Do your own research. From my own research, I decided better safe than sorry, so I grounded it to the metal frame. That's what this extra cord is for too, is for the ground post on my inverter. All of the circuits end up running through this cable to here, through the battery shunt, and then the other negative post of the battery will be connected here. This is how it collects data on how much power is being used, how much power is coming in for charging. There'll be a RJ45 cable that connects from here to my battery monitor. And that's what these little cables are for. This just powers this, and then this one is gonna power my inverter Bluetooth dongle. Okay, so now you've seen all the cool features of our electrical system. Everyone gets to create their own system, something that's gonna work for them. But how do you go about doing that? Well, one of the first things you're going to need to do is figure out how much power you're going to need. You need to write down all of the devices that you're going to charge in a given day. Write down all of the appliances you might need, such as blenders, light, fan, cooler, and then go online and get some estimates about how much power that is. There's also some online amp hour calculators that you can use. This information is going to come in handy, so you might as well make this list and keep it with you. The 2 places that helped me the most during my research, and I apologize if I say his name wrong, Will Prouse. I'll put his name here. He's really great about showing you how to plug in a lot of these components, about giving you the basic understanding about an electrical setup. He's got really great information on solar charge controllers, batteries, all kinds of stuff. Another great resource was Explorus.life. They have a website with all kinds of different diagrams. He's also got videos on just about everything. So those were my two biggest tips for doing your own research. Another thing you're definitely going to need and use a lot is the wire sizing charts that you can find online. I'll post a picture of it here, but if you just search wire sizing chart, you're going to find it. Keep in mind when you're trying to figure out your wire size that the length of the circuit is the entire circuit, the positive and the negative returning, from the battery all the way to the appliance and all the way back to the battery. And if you don't know how many amps the appliance or device that you're using is going to draw, just find out the wattage. Almost every appliance will say how many watts it uses. The equation is watts divided by voltage, and you'll figure out amps. Once you know how many amps you need, you can figure out using the wire sizing chart what size wire you need. Small wires are large numbers. Large wires are small numbers. Your smallest wires are around 22 to 24 Ogg, and they get smaller all the way down to 1. And it goes 1/0, 2/0. 2/0 being bigger than 1/0. 2/0 is the largest wire that I use in my setup. Once you know the wire size that you need and how much amperage that wire can take, then you can figure out what fuse size you need. You need a fuse on the positive side that is slightly smaller than the amount of amperage that wire can take. So if you know that wire can only take 15 amps, but your appliance is only going to use 5 or 7 amps, then you want to put a 10 amp fuse on that line. So that's how you figure out your wire sizes and your fuse sizes. And remember, if you're running multiple appliances, multiple outlets, or anything on one circuit, one wire, you need to add up the most that you might use at one time. So now you need to figure out your components. What components do you need? The major component is batteries. You're going to need to decide if you want AGM batteries or lithium batteries. AGM is much cheaper, but you can only use about half of the battery capacity before it starts damaging the longevity of the battery. Lithium is going to be much more expensive out the gate, but they last up to 10 years and you can use the full amp hour storage of them. We personally have two 100 amp hour lithium Battleborn batteries for a total of 200 amp hours. Now you take that list of all of the appliances you're going to have, all the devices you're going to charge in a day, add it up to see how many amp hours you will need. You can find amp hour calculators online to help you do this. Now that you've figured out the batteries, you need to figure out how you're going to charge them. There's three primary ways of charging batteries for vans: solar, inverters/chargers, and alternator. Our setup, we currently have 350 watts of solar power, as well as the inverter charger for being able to plug into shore power and charge our batteries. We may opt later in the future to add a connection to our alternator to charge the batteries that way. Wires. You're gonna need wires, and you're gonna need a lot. I had to buy more wire multiple times because I ran out in my build. You don't think you need a lot, but you do. Once you actually tack it all down in a way that looks neat, you're gonna use a lot more wire than you think when you first tried to measure the distance between two locations. Keep that in mind. You're gonna need connectors. Different things have different terminals for connectors. Connecting to your battery is different than connecting to your fuse box. Common ones are butt splice connectors. Those work great for connecting two wires together. Spade connectors, like the fork shape for outlets or for connecting to switches. And then you're also gonna need lug ring terminals for like bolting to your battery and to your bus bars. You're gonna need lots of bolts, nuts, washers, locking washers. A lot of the equipment will come with those, like your batteries, but some things won't. You're gonna need switches if you want to control things like lights. You're gonna need outlets, whether they're 12 volt or 110 volt. You're gonna want a battery monitor or some way to be able to see how much charge you have and how much energy you're bringing in from your charging option. And you're gonna need a distribution panel. This is what makes it really easy to control the fuses and breakers. Other things you're gonna need is things to manage your wire. You're gonna need different size clips, zip ties, anything to really get your wire management under control because it's a mess. You'll see in the video, it's a mess. You're gonna wanna create a wiring diagram. Write down exactly how everything is gonna be connected. And I recommend that you show that wiring diagram to people and get their advice. Go online to a VanLife group or post it on an Instagram or just ask an electrician to look it over. Make sure that you've got the right wire sizes, the right fuses. There's built-in breakers and there's these A&L bolt-on fuses. There's a couple different options. Check it out. In the future video, I'm going to show you the detailed walkthrough of how I installed the Shore plugin, how I installed the garage light, how I added the crimp connections on the end of a lot of my wires. More tips, more tricks, more of the nitty-gritty on how to do this stuff, as well as seeing all the cool time lapses of me running these wires, plugging everything in. So stay tuned for that video. That will be next. We took this on a trip to the lake. We had it plugged in all weekend. We were able to run an electric heater inside, have fans going. It was wonderful. It really changes the comforts of your van when you have all of these luxuries. But I really hope this video is helpful for you. I hope you enjoy our electrical setup, and don't forget, like, subscribe, share, comments, questions, and be on the lookout for that next video showing all the great detail that went into this. Got some bonus footage of me riding an electric scooter, one of the world's fastest. My buddy let me try it out because I'm interested in bringing some kind of electrical vehicle in the van that we can charge up and use when we're traveling. So check that out. See you next time.
What's up, guys? Taking a little break. My buddy Ryan, who is GingerOnWheels on YouTube, has these really awesome electric scooters. He's an electrical vehicle enthusiast. He's let me take a ride on one of these things today. I got his actual like customed out one, and these things can move. I'm excited to try it out. Check him out on YouTube, GingerOnWheels. I've known him since high school. He's a really good guy, and his YouTube channel is awesome. But we're about to take it for a ride, so I'll show you guys. Ready? Yep. Slippery in there. Man, that was a crazy ride, but a lot of fun. This is my buddy Ryan, which is GingerOnWheels on Facebook. Ryan, you want to tell us which scooters we were riding?
Yeah, absolutely. So this scooter is called the Kaabo Wolf Warrior. It's the best off-roading scooter on the market that's available. You can buy it from Fluid Free Rides in Miami. This scooter is called the 011X. It's like a really super fast Land Cruiser. You might have seen me going 50 plus miles an hour on this thing. It's out of control. You can buy this from Rev Rides in Vancouver, Washington. They're both amazing scooters with amazing customer service. If anything goes wrong on either of these scooters, they'll ship you free parts. They got your back, no worries.
Yeah, so check out his page, and if you have any questions, I wanted to check him out really bad because I've been considering some kind of electric vehicle to bring in the van, so when we're parked, if we want to do a grocery run or just go on a leisure trip. So I'm gonna have to do some research on the batteries and stuff because it's a lot of fun, man. And I think I topped out at like 42 on the streets, only in the second of 3 gears. Yeah. And off-road, I was doing at least 20. I wasn't looking at the speedometer.
Yeah, this guy was absolutely killing it off-road for a first-timer. I wouldn't expect to do what he's doing. Like, these are complete super scooters, but if you want to get a step down, there's a 010X scooter also. Still really fast.
Yeah, these are like the 2 fastest scooters on the internet right now. So thank you so much for letting me check it out.
No
that was
problem.
great.